హాయ్ అండి, గుడ్ మార్నింగ్.
Good morning, Ramesh. You all okay?
ఓ, రంజన్ రాలేదా ఇంకా?
Mm, sure.
ఫుల్ బిజీ అయిపోయారు మీరు. టైమింగ్స్ కూడా చాలా హార్డ్గా ఉన్నాయండి బాబు బాబు, మీకు నైట్ మిడ్ నైట్.
అవును అవును. నో ప్రాబ్లం అండి. ఈ రోజు రేపు చూసుకుందాం కూర్చున్నాం, ఓకే?
అదే ఏంలా కొంత తొందరగా వస్తే మళ్ళీ మేము గేదప్ అవ్వాలి కదా.
అర్థమైంది అర్థమైంది నాకు.
ఉమ్,
ఓకే మరి లెట్ us స్టార్ట్ అండి. నేను రంజన్ మీకు ఆల్రెడీ చెప్పాను కదా టైమింగ్స్ కదా 1 PM అని చెప్పి మేబీ విల్ జాయిన్, ఓకే?
ఉమ్,
ఎందుకంటే మనం కూడా వెయిట్ చేస్తాం కూర్చొని
ఉమ్.
ఓకే సో వీ డిస్కస్డ్ అబౌట్ ద లాజిస్టిక్ రిగ్రెషన్ అండ్ వీ వర్ డిస్కసింగ్ అబౌట్ a యూస్ కేస్, correct, right?
ఉమ్.
The predictive maintenance use case. Did you get a chance to look into that?
Forget actually after that.
Okay, anyway, let me recap and show you how the application is going to help us.
There
Okay.
was, yeah. Actually,
Yes. Uh,
Ranjan and you tried, but it did not work out.
that's
If
why it is
we,
working now. Let me show you.
yeah.
But you remember what we discussed?
Uh, that
Let me recap. So the use case is basically
he's asking the link actually.
no
Same
no
link,
no
right? I told him same,
same link
same link.
same link. And
Uh,
what I was trying to discuss on previous class is a manufacturing use case
mm,
implement using this is Snowpark ML.
ah,
So Snowpark we discussed already. How to
yeah.
go to use Snowpark and how to do data management and all. We are using now Snowpark for ML.
Mm,
And we are learning Snowpark with ML models. And where this ML model, every ML model, we are learning with some use case.
mm,
So just a minute. So the use cases which you are learning is model wise you are learning.
mm.
So model wise in the sense first we learned a linear regression model where we predicted a numerical value.
He's asking to share the link. It is just
The same link, right?
paid Snowflake agentic AI training
Wait,
7
wait.
a.m.
And
batches.
no, no, let me ping him. Maybe
Just
the same link. I think because
uh,
I
s-
also do
what?
this.
Yeah,
Wait.
what I noticed, no.
Uh,
I also get the same thing like this. Same link, but it is showing sometimes 7 a.m., sometimes 8 p.m. Now it is
no, no,
showing 8
no.
for me.
Whatever the link you just opened,
Um,
I'm just pinging that. Just a minute. Just a minute.
uh, WhatsApp is not there in my laptop.
Yeah, I just pinged the link
Yes.
and he'll join. You can see my screen, right?
Yes.
So we discussed about Snowpark and what is Snowpark and all, but the manufacturing perspective, how Snowpark we can use and we can implement a use case. That is what we discussed about.
Yeah.
The use case is basically every manufacturing process will experience some part of challenges with the maintenance of the machines where your machines will go down generally.
Mm,
That is
mm,
one of the biggest problem for many supply chain companies also. If the
mm.
machines will go down, ultimately what happens?
Productivity
The
will down.
yeah, the
Yeah.
production will be delayed and it will be
Mm,
the process will be broken and the maintenance whatever you are doing requires additional manpower also.
correct.
And we don't know when it will go down and it may go down or sometimes it may not go down. but we cannot guess. Correct, no?
Correct.
So to prevent that downtime or prevent the machines to go down, what we have to do, we need to have a process which can help us to identify or predict whether a machine will fail or not. In
Mm.
24 hours in advance, if I can find out,
Mm.
I can take an action, correct, no?
Correct.
And I can go and ask the team to take care of it.
Oh.
But I cannot go 100% predict it, to be
Is
honest.
it IoT kind of thing or?
Yeah, obviously, like, obviously.
Oh,
The IoT
okay.
devices will be keep on monitoring the machines and they
Oh,
may send the messages whether the status
mm.
of the machines as a sensor data.
Yes, yes, yes. Understand.
But
Mm.
what they require. So when I'm dealing with this kind of applications, I need sensor readings also.
Mm.
The IoT devices will capture the sensor data, and the data my system has to analyze,
Snowflake, yeah.
and then it has to predict whether the machine is going to be down or not.
Mm.
So this particular logistic regression is basically the model which is going to help in predicting the outcome. Like what I'm
Outcome.
predicting can be either 1 or 0.
Mm.
So
Yes, one of them. Mm.
one means here we consider as the machine will fail. Not fail means we'll consider as 0.
Okay.
So since I want to use these kind of algorithms, and it is
Mm.
predicting as in numerical discrete variable, we call it as. Discrete means 0 or 1.
Yeah. Mm.
Since I want to predict like that, so I need to get my data in that form. So whatever the data I am going to have, I need to go and convert that into numerical because this algorithm will look for the data in the numerical form.
Okay.
And this will fall under binary classification. Binary classification in the sense 0 or 1. We are
Oh,
classifying to one of the class.
okay.
0 is one class and 1 is another class.
Mm.
So 1 means I'll have some
It's
particular
fail. Fail.
fail, and 0 means not fail, like that.
Not fail. Right.
But I can use other algorithms like linear regression also, but we don't know how to go and balance it because the cutoff. I cannot go and
Mm.
add a threshold, and we don't know the threshold how much we are going to get every time. So 0
Mm.
or 1 will be the correct one.
Mm.
So any mission can go to one of this category and will try to predict whether a particular mission will go fail or not.
No, no.
Uh,
Yeah.
Fail or not will according to that. And as you mentioned also, the data what we are going to use or require for this kind of applications is called as
I got
sensor telemetry data. The sensor
sensor
telemetry
tele.
data will have the vibration,
Uh-huh.
the mission information. What is the
Okay, okay,
vibration,
okay.
and then temperature,
Mm-hmm.
pressure. All these data requires for every 1 minute.
Mm.
Every 1 minute they capture, and some companies, some manufacturing projects use the dedicated databases for this particular kind of data also. This
Mm-hmm.
data will be time oriented data also. Every 1 minute means I need to capture every 1 minute this data, right?
Oh,
And this will be called as the time series data also.
time series data. Okay.
Time series data specifically capturing every 1 minute, and this kind of data. Some applications like stock market prediction also will use.
Mm.
In the stock market prediction, they will also keep on checking the stock price, right, continuously.
Correct.
So they also use this similar kind of time series data to store this kind of data. There are databases like historian databases where GE came up with one type of database called historian database.
What is that?
GE historian
Okay,
database.
okay. Okay,
So that
okay.
is designed for time series data.
Oh, 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 oh.
So we have databases for even this kind of data. If you use that kind of databases, your processing will be easy.
Mm-hmm.
You do not need to convert because again
Mm.
I need not convert the data to time oriented data to normal data like that.
Okay.
So it will make your life easier.
Yeah, understood.
So if my data is in such kind of databases, extracting is easy because Python can extract any kind of data, right?
Correct. Correct.
So I can use Python, I can go and uh, extract the data, and the data is not only telemetry data, there might be some historical like log files will be there, mission maintenance logs. So
Mm.
why I need that is I want to see last 1 month how many missions went down and why they went down, what is the reason for failure, and I need to get all this information so that my model or system should know what is the reason for the failure. See,
Mm.
if I, as a human, if I also give you some data like that, you can also go and predict, right? Yes or no?
Yeah,
Assume I gave 100 missions data, last 1 month data. What is the temperature, pressure, and what is the reason for the failure, and what is the final result, and how much time it failed. If I give all this data,
yeah. Mm.
and if I ask you what will be the status in next month, you can just guess, right? By looking at the
Yes,
data.
yes, 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 yes.
Because you also will be trained like that in the past data. Your brain will think
Uh,
like, okay, last month on this particular day, this mission went down because of this reason. This month
mm.
also it may go fail because of this reason. You will simply give some like estimation,
Prediction,
prediction,
estimation.
estimation, whatever it is.
Mm.
So what is required here? I need the
Past
sensor
history.
telemetry data plus the maintenance logs also.
Maintenance logs. Okay, okay.
Plus, not only that, we need mission data also, like mission name, mission model, mission age, location,
Yeah.
all is data, correct? No?
Yeah, the telemetry data means every minute
Temperature,
data.
now every minute data,
Uh,
temperature, mission status.
maintain, yeah, maintenance log means
The
which
mission state,
history
mission, like
log,
log
failure.
files.
Understand. Okay. Mission metadata means about the mission
Information about mission like
metadata.
mission age, how old it is,
Okay,
the
okay.
location it is available, last service date. All these are also required, right?
Understood, understood. Three
So depends, hey,
categories.
depends upon the mission age also it go fail, correct? No?
Mm.
As a human, as we become old, how we also will become weak. A mission
Yeah,
also go weak, right?
understood, understood.
Yeah, same like that. So I need to
Yeah.
see the criteria. See, the criteria here mainly
Mm.
required why the mission will go down. So every data is important here because
Mm.
we should not miss any data because this data will help us and become that as a key important factor for maybe the mission failure also. See, a mission may go
Mm.
down because of it is become old also, right?
Yeah, obviously.
And also like according to the mission model type also we can say because a brand model may go like will be strong and a weak company model also
Mm.
will go down.
Correct.
That's why we say I need a brand shirt. Correct now.
Uh,
Even in particular missions also there will be some brand. You have to
yeah,
see
obviously.
old models, new models also.
Mm. Mm.
Correct no?
Yeah, yeah. Model
So
also important.
all
Mm.
this information we require
Okay.
and we need to capture them. We need to capture and as we discussed about all this, as a data scientist, we need to go and extract the data and we do pre-processing also.
Mm.
See, we decided as per our business understanding, oh, this is what the problem, this is the data now, and we decided this is the type of problem like I need to use logistic regression here because I need to classify the mission status, failure status. I decided everything. I'm ready with everything, data, everything. Now my job is to build a model that can help me to classify this data. And before that, what I need to do, I feed this data to the model, and that model will be trained with some training data first. So, as we discussed, if you remember, when you are training any ML model, we will not train with 100% data.
Mm.
If I have 2000 records or 1000 records, as for example, this 1000 records I will not pass to training because I need some data for after the evaluation also to test how my model is. First, I'll train you. That's what we do, right? When you go to any exam also, no, directly you will not get the like all the papers, right?
Mm.
Sample test papers you go and try. And
Okay.
before that, you will have quarterly exam, annual exam, and half-yearly exams, pre-final exams, and then you will go to final exams. Correct, no?
Correct.
Similar to that, my model also should be trained with either 80% or 70% data first. Remaining 30% I will use for testing.
Okay.
So training and all you can consider like your quarterly, half yearly exams and all.
Got it.
And pre-final can be testing,
Mm,
30%.
okay.
Any new data I'm training after my training completed, evaluation completed, model deployed. Now I am using in live. That is your final exam.
Okay.
That's what generally will happen, right? Your productivity or whatever it is, your strength will be evaluated in the annual exam only.
Correct, correct.
Even my ML model also should be evaluated in the production only, right? I cannot go
Yeah.
and say in my development it is working very good and
Mm,
I did very well in a quarterly. I cannot go and confirm that I will do the same job in an exam also.
mm,
According to the test paper what I receive in the annual exam will decide. Correct, no?
yeah.
Same
Got it.
like this. My new data
Understood,
production, live
understood.
data also will decide sometimes.
Uh,
That is the reason we have to train as much as possible.
okay, okay.
The same thing, same concept.
Mm,
Just to compare yourself with the model.
got it.
Even if sometimes the model will become old, also will go and the performance will go down because the same concept. If we
Yeah,
become old, we will not get trained. What happens?
yeah.
Same thing, same thing.
Understood.
So
Okay, got it.
continuous training is important.
Mm,
The continuous training of the model important, and you need to keep checking the model which is running in production continuously is important.
mm.
You got it right?
Understood, understood.
Yeah. So this particular model, what we are now leveraging, so it requires some set of libraries since we are using this Snowpark. So we need to install these libraries which are required, like both scikit-learn, pandas, and Snowpark, and also Snowpark ML as well. And your account need to be configured here because we are dealing with Snowflake data. Because my
Mm,
data is sitting in Snowflake, so I need to connect to Snowflake. So we also need to configure Snowflake connection here with your account details and all the other information.
mm.
So when you are running your code, this will be one of the place where you need to configure your like a Snowflake
Snowflake
environment
account.
connection.
Mm,
And this is going to open a Snowpark session that is going to help you to run your entire program.
mm.
And if this is not going to be available, I cannot go and run my Snowpark code because Snowpark requires a warehouse here.
Uh,
Without warehouse, we see the warehouse in the down there is a warehouse name.
yes.
That is required because you need to give the correct warehouse. That too, since I'm running Snowpark related code, I need a Snowpark optimized warehouse.
Okay.
There are types, standard
Yes.
warehouse, and then generation 1, generation 2, Snowpark. Now
Yeah.
recently a new type of warehouse also came in Snowflake.
What is
Like,
that?
I think interactive, I think so. Interactive
Okay,
warehouse,
okay.
something like that. Yeah.
Gen 2, I know. And other
Gen 2, after Gen 2,
Snowpark is there.
there is one more type came now.
Uh-huh.
So if you
Okay.
go and see,
Mm,
see now a new type came that is not Gen 2.
mm,
That is, I think, interactive warehouses also have been added. Just recently only.
uh,
We go here and see in the compute warehouses. We have interactive warehouses and interactive tables also. If we go back and run this, in the type, you see standard generation 2, what you are talking about.
mm.
And also,
And Python.
I have generation 1 is a
Uh,
standard, the first one.
Later on,
Generation
mm,
Snowpark optimizer came into picture.
yes, yes.
And then
I,
generation 2 for this generator applications.
uh,
Now we got interactive also warehouses.
this one I don't know. Yeah,
It
interactive.
it came just I think a month ago.
Yeah, okay.
Okay,
Got it. Yeah, yeah,
so
yeah.
we will use generation 2 can be used, but since I'm using Snowpark
Snowpark.
optimized,
Yeah.
so I use Snowpark optimized. This one
Mm,
demo
mm.
Snowpark warehouse. Okay,
Okay.
that's what I added here. Okay,
Understood.
so now this particular use case, whatever I'm talking about, this is, I hope you understood, right? The outcome,
Yes, yes,
the
yes,
outcome
yes.
and all, like, so my
Yeah.
requirement is I need to
Machine
go and
learning,
load the data,
one, yeah.
and then I need to go and pre-process and then build ML model, and on top of that I need to go and train my model, correct? No? So
Hmm.
back in the back end it can do anything, but at the front end I should have provision to upload data and get
Yeah.
some predictions.
Yes.
That is main thing which every user will look for. See, as a user, what is my requirement? If I am a user, I will use the system,
Yes.
whatever the
They
data
give
system
data.
built, and I'll go and try to log in into that, and I try to see if I
What is the
upload some systems data, it has to give me what is the status.
end of the day? We have to give the status.
It has to, so maybe I can give a provision to the user to upload a CSV file, example.
Hmm.
So what they can do, they can go and create a list of machines and their statuses. They can download from the application also,
Hmm.
and just upload the file, and it has to show me, oh, this is the
Hmm.
mission, and next
Hmm.
1 week or 2 weeks, maybe
Uh,
this will be the status.
1 second, I'm getting that. You can continue. I will just.
Yeah.
Hmm.
So let us take that particular application. Let me run that. So in from the Snowpark ML, we have to load or import all this, because all this required for maintaining this particular model. So linear model will contain large regression, and which is for the model development, training and testing, and pre-processing contains standard scalar, and the metrics is for model evaluation, and the session is basically for start a Snowpark session. So where you are going to use these correction parameters, and we are creating a Snowpark session here. Once my session is ready, then I can start like generating some sample data. Here we are generating sample data by using the random parameter, sorry, random module and random function from NumPy. We are generating some sample data, mission sensor data, and where you are converting that into a Snowpark data frame, and then finally you are calling that to generate the 80% 20%. So 80% for training, 20% for testing. So this will become training data, and this will become testing data. So my target column is here, the failure label. It can be 0 or 1. And other parameters or factors which require to predict this value label is all this. Air temperature, process temperature, rotational speed, torque Q, and all we are using here. And then we are trying to scale up the data to single scale using standard scalar, and the largest regression is the algorithm. So we are using that here, and we are passing the
Input.
the training data. And what is the target column? Training data is nothing but these four, this all this.
Okay.
And then target column is nothing but failure label 0 or 1. I'm passing here. Okay. And
Hmm.
finally, my prediction will be in the predicted failure. After I upload the data, I need to see the status, right? Finally,
Hmm.
assume I
Hmm.
uploaded like maybe 100 missions data. I need to see what is the final predicted status, whether it will be 0 or 1.
Hmm.
You got it right?
Yeah, yeah.
So the training will happen before with a training DF. Training DF is nothing but this one. Okay. And once my model is trained, here, whatever you see, the fit function is training my model. My model is the model variable, and that I am using for prediction, if you observe here. And what data I am passing? The 20% testing data. and this is going to predict for my testing data 20% data and store in result df. And then we are also calculating what is the accuracy score, whether it is going to be 80% correct or 90% correct, it is going to give us. And then we are trying to go and display all these details. What is the accuracy score, all this stuff. And we are trying to pass the sample data, and we are predicting something to test it. Like I told you, right? Live data. Just like, as I mentioned, your annual exam, how you are going to directly write. I need to upload some sample data and test it. Okay, let me try to run and see this. And we will go and try to run that. Just give me a minute. So how to run? Since it is a Streamlit application, so I need to go and run. So I need Anaconda Navigator. And we'll go with the VS Code editor. And we'll see this is what the application. And whatever you see here, the data is my system is generating some sample data. Whatever you see in the down, can you see that?
Mm-hmm.
And mission ID, the air temperature, process temperature, rotation speed, these are all factors. If the temperature increases or like temperature increases or decreases, the rotation speed also increases. So all these factors will impact my system, like will go and fail or not. Correct, no?
Mm-hmm.
Generally, how a system will
Ju-
go fail according to temperature, pressure only, right?
uh,
And speed, rotation speed, all these also matter.
uh,
So according to this particular criteria, this is the sample data. You understood, right?
mm,
To 80% data, it is showing the top 5 rows. So out of my 2000 rows, 80%, which is
mm.
what is 80% of 2000?
1600, huh?
1600 rows.
Mm,
So when I click on this train model, it will go and take the 1600 and it will get trained, and also
mm,
remaining 400 it will go and test it, and it give the evaluation also. See, it is doing now.
mm.
In the background, it is running the a stored procedure to train
Good.
and test my model, and it will try to keep my model ready. Then I can go and upload some data here. Can you see second tab?
Mm.
Here I will upload the sample data.
Then first one?
First one is for training only for training and evaluation.
Uh,
So keeping you ready for your quarterly, annual exam,
uh,
and
okay,
I'm
okay.
doing
That
that
is
now.
final. That is final exam,
This
right?
is the final exam, correct?
Predict. Okay, okay.
So I need some model ready. See, my model has been
Mm,
getting trained. This training is
mm.
completed. Now it is evaluation, testing data.
Got it. 70 plus 30. After
80,
that,
no,
like
80 plus
that.
80 20.
80, 20. Mm.
But people use 70 30 also, but 80
Mm.
20 is the common practice.
Okay.
See, more you train, you get more better accuracy. Correct, no?
Obviously.
See, 80% is better than 70%. Always remember that.
Mm.
You understood, right?
Yeah.
See, evaluation also it is, see, accuracy score 92%.
Mm.
And you can see in the down, so it is predicting the failure. Can you see that?
Mm.
So now I can see some missions, one means they will fail. So let us try to pass some sample data. And the sample data, you can go back and browse and see, I can upload any file, either CSV or Excel files. I gave the option
Mm.
here. And the
Mm.
size also should not be greater than 200 MB.
Okay.
So let me try to go and upload the file.
But generally it have TB size of data, right?
Can be. I need to
Uh,
go and connect to database.
just
Generally,
yeah, okay.
this is for our understanding. Okay.
Uh,
See, I just uploaded the sample sensor data.
mm,
So this is the top 5 rows. Okay.
mhm, mm,
And if you click on predict, it will go and use the trained model and it will try to predict and give us what is the status of every mission now. You'll get one more column extra here.
okay.
The
The
predicted failure.
prediction. Uh,
0 or 1, it will highlight. It will
mm,
highlight the
failure.
failures also. Let me see. See, it is highlighting. Can you see that?
Uh,
1. Wherever 1 is, it is highlighting. Can you see that?
mm,
See, these are all the machines which may go down. So we
mm,
are giving some like a solution, correct or not?
yeah.
To the operators, the line operators in the manufacturing plant, the factory
Mm,
workers who will be working.
mm.
We are giving them a provision to pass some data and they can go and
Take that
see
one.
which emissions will go down and then take any precautionary action also.
Mm.
Correct, no?
Correct, correct. Understand.
So see, this is 200, like I mean 1000 records. I'm just passing as per
Mm.
as a what I can say uh, evaluation,
Sign.
like live data.
Mm,
You can just assume.
mm,
And so what it is going to give us, you can also download also. Can you see that?
mm.
You click this, is download the results
Okay.
so that they can go and take and they can connect to dashboard also, right? They can go to dashboard and they will
Yeah,
see this
definitely.
data. They can connect to Power BI dashboard and they can review also.
Correct.
Or I can place a dashboard here itself. See, instead of after
Steam
this,
it.
but streamlit dashboard. One
Uh,
more tab here in the down. I can even show them my analysis on the predicted data also.
mm.
You got it?
Yes, understand.
So that they can see the status here itself instead of going to other tools.
Mm,
So the data, whatever, I can also increase. I can increase and I can see it was 1000. I change it to 4000 now.
mm.
I can even change it. My training of data, I change it to 4000 now. Can you see that?
Okay, okay,
I
okay.
can increase. I can increase. See, it is changing now. See, according to my selection, it will generate the data.
Mm,
If I need 10,000 records, it will go to 10,000 records and it will train my model.
mm.
See, now it is going for 10,000 records and I can train now.
Okay.
If I want to go with only 1,000 records or 3,000 records, I can reduce.
Mm,
I'm giving a provision also. Hope you are getting. Is it clear?
yeah.
See, this is particularly how you are integrating your predictions with a particular system interface.
Mm,
So this is basically a logistic regression. Why it is we are calling this a logistic regression? Because my outcome is 0 or 1.
mm,
Normally, if you go to any classification model, apart from logistic regression, other models will go with the categorical data, like
mm.
high, low, medium, yes or no, true or false, like that. So the next algorithm which we need to understand is the decision
Pattern.
trees. See, decision tree also similar to logistic regression, but my outcome will be not 0 and 1. It will be
The sun.
categorical, true or false, or yes or no.
Okay.
Okay, so
How can we continuously upgrade that model? Like continuously we need to update, right? Otherwise, that maybe
you have to
gives
schedule it.
some.
You have to schedule on a daily basis. You need to go and connect to a database, and whenever data will come, we need to go and keep on training the model. So whatever we did manually now, correct? No, we're uploading and
Mm,
manually training, right?
mm,
Mhm.
So,
No,
what I'm
so
doing,
that's
I'm
okay. No, no. what I'm asking, so first day, let it be that first day 80%, 20% you made it, right? From the second day
Correct.
when the data comes, what you'll do from the
You-
second day?
That's what I'm saying. Every day you need to get refresh the data, right? If you connect to database, my table will be automatically refreshed. Incremental
Yeah,
data.
so you mean to say on the second day also we'll do full table refresh, like
No, 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 no. You do the incremental data only, right? The incremental data, whatever you receive, just train with that. Why?
on that incremental data, 80%, 20%?
Yeah, that will be better always. See, every day you want to train in the sense the evaluation, if at all you want to see on a daily basis, you have to go with that.
Okay.
If I don't want to do the evaluation on a daily basis, I only want to train, I go with only eight, no need to go with 80%, 20%, right?
Hmm.
So why I need evaluation? The first time when you are verifying the model, I need evaluation, correct? No, for my understanding. But
Right.
every day I do not need. Maybe once in a week you can go for evaluation, correct? No. And that
Hmm.
too, you should get some notification that this is what my accuracy score by on this day. Correct or not? If at all I want to
Hmm.
test my model, I can go and test on my. I should have a provision to test by following some passing some sample data and test. No,
Right.
so I cannot go and daily go and do the evaluation. No, if we need it, let it automate. No, that process also.
Okay.
Every day you go and train it and evaluate it and get a notification, email notification of the status of the model. Why I will go and do manually? No, correct or not?
Right.
So whatever the model running in production, keep a like a schedule that a email notification that let it daily train with the new data and get the
Hmm.
status of the model every day so that it will be easy for us also. And we can see the health monitoring, right? Correct or not? If something
Yeah.
goes wrong with the model and the performance is going down, I'll get to know, right? Correct? Are you
So that
getting?
email, is that email we should get that 90% accuracy, that one,
Whatever it is,
right? So
correct. No, I can see instead of 90% or 20% accuracy, I can go and get like how my model performance is up to the mark or it went down. That if you get that will be better, no? So
okay.
today, maybe yesterday it was 90%. Today it went down to 89%. Then something goes wrong. Something went wrong. Correct? No.
So in that case, what we will do again?
We have to we
Again,
have to go. No, we have to go and retrain. Right? We
okay.
need to go and retrain the model with the new data, and we have to see the new model is which is better than the old model. I need to replace it. See, that will not be
Uh,
done immediately, right? I need to find out the root cause also. Why it went down. See, my
Suppose
model which is hmm,
yeah, go
my,
ahead. Go ahead.
so no, my model which is running in production. Why it went down? It may sometimes you'll come to know immediately, or it may need some time to analyze also.
Hmm.
But the failure happened. That is notification should come. If I don't get the failure notification, how can I go and come to know?
Right.
So generally, that is in general called as model drift or data drift in ML like terminology. If a model is facing a drift means its performance is going down. So model
Okay.
drift means my model which is performing very good yesterday, it is not performing good today. That may be because of my model variables may have changed, data type may have changed suddenly, and
Hmm.
sometimes maybe the seasonality may impact. Correct? No,
Correct.
the seasonality impacts on a particular season. There are no sales at all. Maybe COVID time is a sudden drift, right? People never expected that COVID will come and that will impact no so many businesses. So that is called sudden concept drift. There are so many types. Even in the model drift, we call it as sudden concept, gradual concept. So we need to see what kind of drift we are experiencing. So over the time also, my model slowly will go, performance will go down. That is called gradual concept drift. or that is called concept drift or model drift, both are same. That is sudden, it may happen sudden also, it may happen gradually over the time also. So I need a system which can keep on monitoring it and it should communicate me on time. So I should have an L1 monitoring team also, right? Right or not?
Yes.
See, I need a L1 monitoring team who will be keep on checking how application teams will be there, L1 application team, support teams. I need a L1 support team for my models also, correct or not? L1, L2, L3, both should be there. L1 will like monitor and keep on notifying if any issues, and L2 will should be, if required, they should provide the immediate solutions in production, and L3 is the development team.
Mm.
If really code change required, then it come to L3. If the data changes are on-fly changes, L2 will take care of. The same thing we
So,
follow in application support also, right?
right.
They here also have to follow the same. But how can I monitor this model performance and all? We need to use some different tools like Grafana and Prometheus. These tools can help us generally.
What is that? Can you
Grafana dashboard.
uh,
So Grafana basically will the particular Grafana is for capturing metrics. So metrics in the sense it can be database metrics, performance metrics, or model performance metrics, or pipeline performance metrics. We can generally capture using this particular Grafana, and then one more tool called Prometheus.
Mhm.
So Prometheus will capture the metrics and it will go and pass on to Grafana. Grafana will display like a dashboard. For example, let me show you. So how it will be generally a model drift and data drift. This terminology is generally used in the ML ops. Okay.
Okay.
So in the ML ops, this terminology is very quite common. Let me show you. Observe here. This is basically the model monitoring and using Prometheus and Grafana, what you see. So there are tools like this. Can you see that? So here we can see this metrics, model metrics and all.
Mm.
You can see what is my model is doing. It's also not looking good. Let me go to the actual Grafana labs. You observe here. Here you can see now. There are some changes. You can see the fluctuations and all this. So there is a library called evidently, Python library, that evidently is designed for majorly for evidently AI. So this will go and capture the model drift or data drift, whatever it is. You can check. This is one of the popular library now in the market. So it will allow us to see uh, how many features are experiencing that columns. Can you see that, both of you?
Mm.
So
Yeah.
this can be also built to monitor your model. Ranjan, I hope you are following.
Yeah.
So this particular evidently can capture my model metrics, and that captured metrics can be used with. So Prometheus is for capturing metrics. On the Java Prometheus is go and capture the metrics, and it can capture from any tool. So maybe from
Mm.
evidently Prometheus can capture, and there will be a Prometheus integration in Grafana. You got it right?
Mm.
So here, my machine learning model metrics will be captured by evidently to
Mm.
Prometheus to Grafana. So get the metrics from evidently. Then and it will connect to Grafana as a data source and it can showcase. You understood, right? The process. My ML model, I may generate accuracy score, F1 score. These are all the metrics. If you observe here, in my script also, I'm generating them. In the last, if you observe here, I'm generating some metrics here. Here, can you see that?
Metric
Okay.
accuracy, precision, recall.
So these metrics, whatever you see, metric. Similar to that, we have a metric called model drift and data drift also. Those metrics, machine learning model metrics can be evidently can capture. Evidently is a Python library. So it has some functions to capture them. As soon as you capture them, it will be passed to Prometheus tool, and Prometheus can collect them and pass on to Grafana. So this can be created as a dashboard. You got it right? What I'm trying to say? Like this. And this dashboard, you can see the fluctuations can tell. And this red color indicates there is a problem. Correct? No.
Okay.
My L1 monitoring team should have the access to this kind of dashboard so that they can look into them, then they can send an immediate notification. Correct? No. So here it will clearly give the what is the problem with the every column also. You see here why it drift. Sometimes what happens, my data whatever I'm receiving, suddenly the data distribution will change. Like for example, yesterday the data is good, today I got some bigger values, large values in the data.
Okay.
So what will happen if I get a extreme values, it will impact suddenly. I should not get data like that. It should be when I'm receiving data, it should be normal data. So suddenly if you get in new data with some different changes, that's definitely there is a problem, right? Example, like a bank transaction. Suddenly there is a big, huge transaction happened in that account. That can be because of money laundering also, no? Fraud transaction also, right? Correct or not? So we have to see. So this particular data drift can capture such kind of issues. If any changes happen with respect to data drift is the metric. If it's a model specific, that is model drift. So these metrics also I should capture, correct? No. So what I have to do in this model, whatever I'm capturing, the metrics, along with those metrics, I also need to capture not only the data like this particular accuracy score and all, I also need to capture the model drift and data drift also, correct? No. Then I can easily integrate, right? Yes or no? Both of you. So that is what we have to think finally. So capturing the metrics and integrate with your dashboard so that the team can keep on checking it. Anything goes happen like if it's going smooth, it's okay. If something is going wrong anyway, you will be notified and you will take an action.
Okay.
So you have to think your application should build like that. Correct, no?
Yeah.
So that is about large tree regression. Similar to that, a decision tree also one of the algorithm which will classify the data specifically in a categorical. Assume I have a life insurance use case. In this life insurance, generally what happens, a insurance company means they will try to look for people with who are there giving life insurance premium. They go for some criteria. Medical history they will see, correct? No? If someone is giving you life insurance means they will not give for directly, right? They will verify. How the bank will verify your credit checking. Similar to that, a life insurance company will do your health checking.
Yeah, they will check. Then only they will do.
Medical history they will see.
Yeah.
Because according to your medical conditions only, they will try to give some terms and conditions also. You are a smoker, your premium will increase, right?
Yes, yes.
They will capture your then generally the personal data will not share, should not share, but then sometimes for some kind of requirements you have to provide, correct? No. Since you are providing, it doesn't mean that the insurance company has to disclose that, right? The company has to secure our data also, correct or not?
Yes.
You have to protect. That is called PI security, personal information security. And PHI is very much important in US kind of countries. People
PA also yes, right?
PI okay. So PI even if they don't worry, but if you go and share health information, right? They will have a right to put a case also.
Yes.
Very critical, very critical. So people, healthcare companies are will be very afraid of this kind of things. So they will not disclose. That is the reason. Healthcare information you should not disclose with anyone in US. If you share means you are gone. So very very strict. At least PII okay. There will be a little bit liberal. Not everybody will be okay, but that also critical only. But PHI is very critical because nobody wants their health condition to be shared with others.
Okay.
So we should not leave the data because people will be very very particular about this healthcare, health information and all. So assume that you got a requirement to automate your data, what you are receiving from the customer information. I want to go and categorize the risk level. Risk level will be there, right? For every like life insurance customer, there will be a risk level where based on the customer health and lifestyle, we also need to see how to automatically calculate the premium pricing, correct? No, because of the age, some people age is more. That also will matter, right?
Age habits based
Age,
on the
habits,
premium.
food habits, and
Health history.
everything, health history, everything. So according to that only, they will calculate your insurance premium. Correct, no? But we cannot go and manually calculate everything. I should have some process to do that.
Correct.
And my system has to capture all this information and it has to automatically give me what kind of risk if I go with this particular customer. Correct, no? That is important. High risk or low risk or medium risk. I need to classify. Every customer I need to give it, and according to the risk level, I will go and increase the premium. Correct, no?
That is also automatic, right? Automatic, right?
Automatic,
Premium also.
everything automatic only, but I need some criteria to
justify.
Justify and calculate the premium, and the customer will ask why this much premium for me. Correct, no? I should say you are at high risk. You are in medium risk. You are in low risk. I need to tell them, no?
Understood.
So that calculation, how we have to do and all. Sometimes company wise that calculation will change, right?
Yeah.
So every company will have their own way of how they will
Yes.
assess the
Somebody will
customer.
tell.
The formulas will be different.
Yeah, they'll take
How
less profit. Somebody will
exactly? If you
take
go to
more
supply
profit.
chain, every company will have their own way of methodology, terminology. Some people say out of stock, some people say in stock percentage, like that. Similar to that, every life insurance companies also they follow their own way of evaluating their customers premium and all. So how they are going to evaluate, it's okay, but we should know that what is the risk level is important here. That is going to impact the customer insurance premium. So the factors what going to impact that we have to identify. Correct, no? So decision tree is one of the like algorithm which can go and classify the customers risk level according to some conditions here. See, because of the body mass index is greater than 30, smoker is yes, your risk level is this much. Correct, no? So decision tree will do that. See, if you observe here, the interpretability, whatever the decision tree is going to do, it is going to say, since body mass index greater than 30, smoker, yes, high risk.
Uh,
Body mass index greater than 30, but smoker, no, maybe medium risk, like that.
mm,
When I pass the data to the decision tree model, it will try to create this kind of tree, a tree with this particular decisions.
okay.
A group of decisions will be combined and formed as in the form of a tree-like structure by the algorithm automatically in the background. That is why we call this as a decision tree.
Decision tree. Decision tree is categorical. Okay, you can a high medium
Categorical.
risk
Decision
like that.
tree
You can
can be
give 5 or
used
4.
for not only categorical, it can be used for regression also, but 90% people use for classification, categorical.
Mm,
It can be used for regression also, but not everybody will use for regression.
mm,
The decision tree is very popular in the categorical prediction classification.
mm,
So most of the when to go for decision tree also is if my 99% data, no, not even 90, 100% data should be categorical. Every column should be categorical here. If not converted, why I need categorical here? Because I need to test that, right? As a decision. Correct or
mm,
not? See, according to my
uh,
decision means I need some categorical data, no? Correct or not?
mm,
Smoker status, gender, these are all easy for testing. Correct, no?
yeah.
Numerical values can be there, but if I have a categorical, it is easy for me.
Mm,
So categorical handling is very easy in decision tree. That is the reason people go more with this particular algorithm.
okay.
And that is the main reason. Okay, this is what the customer information like age, gender, body mass index, occupation, income. These are all the basic information and lifestyle, smoker status, alcohol consumption, exercise frequency, and then medical history also. See, all this
Mm,
data you have to capture, right?
okay.
It may be in one place or different places. My system has to capture them. Correct, no?
Yes,
Because every information, whatever you see here, will go and impact the premium. Correct or not?
correct. Obviously.
Whatever the like body mass index changes, it will impact. Income changes also
Mm,
impact. Correct, no?
yeah.
Gender also sometimes. Age also sometimes. Correct, no?
Mm,
And then alcohol consumption also. Correct or not?
alcohol, smoking, exercise. Yeah.
If I don't do exercise also, that matter, right?
Uh,
They'll consider. They'll consider.
mm,
Alcohol consumption and smoker status is very particular.
yes. Smoker is very.
Even alcohol also, right?
Uh,
You are using alcohol means definitely they do.
mm,
And medical history also they'll see. Family medical history they'll see.
yes. Yeah. Correct.
Your
Mm,
father is already having diabetes. You will
mm,
definitely there's a chance that.
chance of ticket. Correct.
So they'll look for all this medical history. They'll ask for medical history also.
Correct. 100% by last.
Huh. Any recent surgeries happened also they'll ask you.
Surgeries also.
So all this information they use to as a input data. Correct, no?
Correct. These are input data.
At the end of day, this data only will go with
Process.
the system, and the system will verify, and they'll say we passed your data to the system is verifying. And if you go and ask them what happened to my application, they will say all this, right?
Mm.
We already passed your data to the system, we are waiting for the application status.
Correct.
Correct, no?
Yes.
What is meant by application status? They might have passed it to similar kind of this kind of system, and the
They
system
will
has to predict and give them the premium.
premium price, waiting for price, premium
Ah,
price.
the same thing will happen here. See, whatever you are discussing, the
Okay.
same thing the life insurance agent will do by simply passing or uploading a file of your information, and they'll be waiting for the status.
Hmm.
You understood, right? What will happen now?
Understood. Yeah.
So this is kind of applications only they will also use. Other person might have built similar one.
Okay. Okay. Okay.
So now what I required similar, I need to import the same libraries whatever we were using. Okay, and
Hmm.
we need to configure our Snowflake,
Warehouse,
Snowflake
Snowflake
account,
connections.
and
Yeah.
everything we have to go and see. And you need to load the application history, the customer
Mhm.
application history. And then we also need to go for the by the risk level. See, already there might be some risk level which has been calculated for other customers, correct? No?
Mm.
And we need to calculate the risk level also, right?
Yes,
How many people are at low risk and medium risk and high risk?
that is summary.
Summary. See, sometimes your data may not be balanced also. If my data, whatever I'm training, it is more in low level, low risk level, it will dominate, right? Correct or not? See, my data
Mm.
should be balanced, I'm saying. It should not be 80% low, 10% medium, 10% high, right? Then my model cannot properly go and give me the results. At least it should be a balanced data. Are you getting what I'm trying to say? At least 40% low and then 30% medium, 30% high is okay.
Okay.
Then only it can learn, right? Correct or not?
Mm. Yeah, give an input that I would.
Input data should be balanced, I'm saying.
Uh-huh. Okay.
If there is no balanced data, it will learn according to the data which you are passing, and say 80% is saying low, so every new patient it will calculate low risk only.
Mm.
But that is not correct,
Okay.
no?
Yeah.
So your model, whatever you are training, should go with a balanced data set,
Okay.
not imbalanced data set.
Okay. This is okay.
One important thing which you need to remember.
Mm.
Whatever data you received, you should see whether it is a balanced or imbalanced also you have to cross check.
How to check that one?
This one only, right?
Manually?
This scale is saying, right? This risk level will count
Oh,
and tell me
okay, okay, okay.
how many records are there for risk level low. Low risk how many?
Mm.
Medium risk how many? The
Uh,
percentage is giving me, right? By looking at this, I can tell, right, which is having more.
Yeah.
The 60% of data is low risk means which is not correct, no? Yes or no?
Yeah.
So this particular data you need to balance, and
Okay.
any missing values will be there, correct, no?
Uh,
So body mass index is very important column. If you find missing values in that, that is not correct, right?
not give accurate result, correct. Mm.
So we should see how many records, because maybe the test was not performed by most of the people,
Mm.
means you need to go and ask them to go and get the test and come back.
Yes.
Correct? No, they will say, right, we need
Yeah. They will arrange
this
first
report.
this.
Can you please provide us this report also? We'll ask, right?
Yes, yes, yes.
So
Okay.
this kind of things they'll come to know after this particular kind of verification only.
Mm.
And the risk score we'll calculate according to the age also risk score will be calculated, right? One example,
Yes.
one example, age and everything, body
Yes.
mass index, smoker, gender.
Mm.
So we need to replace, right? Smoker, yes means one, no means one means yes and zero means no.
Mm.
Why we need to do all this? Because I need to convert all into categorical. I told you, right?
Mm.
Male means zero and female means one. We need to do all this.
If you go with the 0 and 1, that will go to earlier
That is
we
not
expect.
going to give the better results.
Uh,
That will
yeah,
impact your model performance also.
correct. Then
So we
why
are
we are giving
converting them.
0?
So no, we are converting them into categorical only. Categorical means not only string, it can be numerical also, discrete also okay.
Okay, okay, okay.
Zero or one also okay.
Mm.
At the end of day, it should be categorical.
Cat.
That's it.
Okay,
Not
okay.
numerical data.
Mm.
See, in numerical also you have categorical and normal data, right? Continuous data. So
Okay.
what I'm trying to say is that the data should not be continuous.
Mm.
It can be categorical. Zero and one is fine.
Yeah.
The decision tree look for categorical means not only like high risk, low risk like that. It can be zero or
Mm.
one also fine. We are
Mm.
converting into zero and one only here. You are getting?
Yeah. Mm.
Yes, we are converting one, no to zero.
No 0.
Smoker also, smoker like that. And even gender also, male means zero,
Well,
female means one. I hope you are getting.
yeah.
So then you are dividing training and testing. Can you see 80%, 20%.
Okay.
And then now we need to go and need to start using decision tree. There is a function called classifier, decision tree classifier, and we need to use it. So let me try to show you in the code. So here, this is the one I'm talking about.
Mm.
The decision tree classifier I'm using here, which I already imported here. If you go and see in the top, I imported decision tree classifier also.
Mm.
Rest all coming from the same module, and we are going with decision tree classifier here. And the decision tree classifier, we are passing the input columns as body mass index, age, smoker, gender, everything we are passing, and my target is the risk level you are predicting. That no?
Mm.
Low risk or medium or high risk only I need to calculate. No, according to that only they will decide the price.
Yes.
They'll have a cutoff. Low risk means they have a cutoff. This is the
Mm.
price, like that. So this model is going to build a this decision tree model, and once after my model is trained with the training data, and once my training is completed, and we are going for a testing
Training
also here.
control. Yes.
And then once my testing is completed, then I am like calculating the metrics also, accuracy score, and model
Mm.
accuracy is coming, how much percentage. And once after it is completed, then we are giving a provision to input the sample data also, if you see a similar way. And it will
Mm.
ask for uploading some sample data like application ID, age, maybe sample data means the new customer's data.
Mm.
And it will go and predict the risk also.
Mm.
Now let us try to run and see, okay?
Mm.
So the one which you see, this is the mission status. And there is one more application. Close this. This is the one I hope. This is the one. Let me refresh. Which I executed already. It is running now. Similar way. This also same. The life insurance predictor. Can you see that?
Yes, yes.
So it has to be my model is already trained. Let me try to run that. It's already trained, I think so. Okay, anyway. So my model is already trained here. You can see here. I only need to upload the sample data of this particular information and see the prediction.
Mm.
Okay, now I'll upload the sample data. My sample data should be a life insurance data, right?
Yeah.
I'll go to that folder and I have a life insurance sample data. It is just uploading, and you can see
Mm.
the output.
Yeah. What is that local host? This one is
My local laptop.
correct only. I mean,
See, when you run
not in
your
PySpark.
when you run your Streamlit application, it will run from your local host only, right?
Mm. Stream it. Okay. Stream it. Right.
So Streamlit, I am running through Streamlit application. So Streamlit always run with your local host
Mm. Yeah.
127.0.0.1. Okay.
Mm.
So it is now showing me predict processing. I need to click on this. Then it will go and generate my predictions in the as a last column.
Mm.
The input data, whatever I passed, it is now using, and it will give me the
Mm.
predictions now in the down here.
Okay. Okay.
And this is my sample data which I just uploaded, and you will see a new column after risk level where you can see, if you observe here.
Mm.
Can you see that?
Yeah.
So wherever you
Risk
see
level, predicted risk, both extra
both,
columns.
right, is the actual and predicted.
Uh-huh.
So you can see the comparison also you can do, right, side by side.
Mm.
You can see side by side, it will clearly show us.
Mm.
Are you getting?
Yeah. Where you have mentioned that highlighted things in your code,
I didn't get you.
say it's a risk is high, it is showing red color, right? Somehow. Just scroll down.
No, where it is showing? No,
Uh, uh,
no, it is not showing.
Somewhere, not some other columns, income or something, smoking status or something. Red color highlighted, right? Few columns.
No, no, where it is?
Eyes, eyes, eyes.
No, no, it is not.
No, in your previous model, you told me, right?
It
Something
was, it
that
was
is,
in that, not in this.
yeah.
The color highlighter you can do in Streamlit.
Hmm. Okay.
But this is basically generated predictions. I
Uh,
can download this
uh,
also
okay.
so that I can go and cross check as a
Hmm.
CSV file.
Hmm.
You understood, right?
Yes, yes.
But you need to practice.
Hmm.
So this is basically a decision tree which can help, which is helping us for a life insurance predictor.
Hmm.
And previous one, a maintenance, predictive maintenance,
Mission, yeah.
mission maintenance prediction,
Okay.
the failure prediction. Correct, no?
Failure predictions. Okay.
See, the mission failure prediction only we did, right?
Yeah, yeah. Failure only, right? Success
That
means
is with
nothing.
logistic regression.
Logistic.
That is 0
Okay.
and or 1. But here
Hmm.
we are going for
Can't get that.
multi, that is binary classification because we are having only two, 0 and 1.
Hmm.
But this is not binary. This is having a 3, right?
Yes. High, medium, low.
This is called multinomial classification, not
Hmm.
binary. That is binary.
Yes.
Binary
Okay.
means only two,
Hmm.
0 or 1, correct, no?
Yes.
But when I say high, low, medium, like that, we call this as
Hmm.
multinomial classification.
Okay.
So we are using a multinomial classification using decision trees.
Okay.
Make sense?
Yeah, understood.
But you need to go also execute this with a streamlit,
Okay.
and then we have to go and need to pass some new data, and you need to go and test it.
So, Sri,
Hmm.
when we create these models, right?
Ah,
Like that logistic regression you said under this decision tree, right? Suppose I have a table,
uh-huh,
I'm doing that one, but my accuracy is coming around 60% or 70%, right? Instead of 90%.
correct.
So, that sense, what we'll do, 60% is my coming as my accuracy, right?
Correct. You not
What?
go and use that, right? You need to use the old model itself. If your model, what you are see, that is the reason continuous training you do, right?
No, no, first time. Let it be. I'm doing it in the first time.
You need to
But
optimize. See, I cannot go see whatever the available data, I can use it. Correct, no?
correct.
If at all you want to optimize it, you have to try with tuning the parameters. See,
Parameters.
every algorithm will have some parameters which you can change and we can get some better performance also. See, everything here is trial and error, okay?
Mhm.
I cannot go on 100% go and predict, right? Correct or not?
Mm.
You need to change the parameters, shuffle the parameters, and you need to test it in thoroughly in development. Correct or not? See,
Parameter in the sense the feature columns and all.
decision tree will have while passing the parameters. Let me show you. See, while passing the parameters in the decision tree, here, if you observe
Mhm.
here, the decision tree algorithm will have some parameters like maximum depth, minimum samples. These parameters we need to change and see. If you change the parameters also, there is one more criteria called a criteria, the column name itself, called gene index or entropy. Those parameters also you have to change and test. Here, you need to add one more parameter, criteria also. And then you need to change the parameters that is called hyperparameter tuning. The hyperparameter tuning will sometimes will give better accuracy also.
What is that minimum sample leaves depth?
Maximum depth means that the tree depth, how many levels you want.
Uh-huh.
So if the decision tree, if you see there are some levels, right? In the decision tree, we saw the decision tree, just a minute.
BMI, smoke, all those things, right?
Smoke, alcohol, health history, accidents.
That greater than, I think that one it passed. It slide, I guess.
Is it?
Now one more down.
Sixth,
Yeah.
sixth.
No, no, wait. I was showing you somewhere.
Yeah. BMI greater than 30, like that.
Even I didn't remember this time when it asked somewhere I was showing you.
It's up only, up only.
Up only, that's what. This is
Those
okay.
pictures.
This is okay. Right? This is okay. This is okay. 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 Okay.
This
Yeah,
one,
this
this
one.
one.
Here, right? So this wherever you are building this, this is one first level, second level, third level, like that.
Oh,
These levels, depth is nothing but how many levels you want. Three means up to three level. Four means four levels. So when you build a tree, it will be starting with root and then branches, right? Root will be at the first level. Next level, like that. Two childs. Again,
Okay.
the child will have two more trees, two more branches. So
Mm.
that is called level. That you can change. The depth will try to provide that.
Mhm.
So criteria will be there. So when you are building a decision tree will use a formula called Gini index or formula or entropy formula to select. See, when you are building a decision tree,
Mm.
this particular features, whatever you are using here, all these are features, right? One feature.
Mm.
So while building the tree, from which column I need to start? That also decision tree should know, right?
Mm.
I cannot go and blindly start with a particular column. I should have a criteria which column I should go with priority. So
Mm.
to identify which column to start first and next in the order, decision tree will calculate a measure called entropy or Gini index. Anyone is fine.
Mm.
And it will
Mm.
start in the descending order, numerical values.
Mm.
So according to that order, descending order, it will select one by one and it will start building the tree. So that criteria also sometimes will impact. That I need to use in the decision tree algorithm here as a parameter here. Are you getting what I'm trying to say? Comma,
Okay.
criteria equal to Gini, I can mention. Or criteria equal to entropy. If you mention
Mm.
that, default is entropy. If you go and change to Gini index, also sometimes your accuracy score may increase.
Mm.
That formula also matter. This is not only for decision tree. If you go to any algorithm, there will be
Okay,
some
okay.
common parameters which you can change and tune, and then you can get better accuracy also.
Okay.
See,
So
your
yeah, sorry, yeah, better accuracy means the
the
parameters should be
percentage,
equal. Percentage should be,
the
yeah,
percentage of your model strength,
uh, all
90%,
are,
90% it may predict correctly, correct, no?
uh,
Or 80%. So I need to increase, right, my predicting power.
mm,
So as of now, my model accuracy score is 85%, which means that out of 100 records, only 85 records it is correctly predicting, correct, no?
mm,
The actual and predicted are meeting.
okay.
15 records are not giving high means it is saying low means high, it is saying something differently. If I
Mm,
increase that 85 to 90, I am doing something best, right?
yeah, okay.
That is parameter tuning, and that I can get by parameter tuning also.
Mhm.
I can increase my model predicting power by fine tuning the parameters also.
Mm,
See, if I improve my model performance, ultimately you are helping the client, right?
yeah, obviously.
So that is can be done. That can be done using parameter tuning also sometimes. See here,
Okay.
as of now, minimum last sample see 5. If I change to 10, it may increase. That you have to try.
Okay.
Correct? No.
Uh,
See, until unless you try, you will come to know? Yes or no?
yeah.
I need to try and I need to go and use and I need to do some R&D. You are a scientist. Correct?
Name
No.
itself data science. Yeah,
See, as a
scientist.
scientist, you need to do experiments, right?
Yeah.
That is data scientist will do by changing these parameters. You do multiple experiments with data. I
Okay.
cannot go and blindly rely, right, on one accuracy. If my model is
Mm-hmm.
giving better accuracy, if I change parameters to some other experiment, I should do, right? Correct or not?
Yes, yes,
Yeah.
yes.
So,
So
for your question, the answer is Ranjan, you are a scientist, so do multiple experiments. Simple.
so even
Uh,
we change the parameters and all, even though it is not coming, so then we can conclude like it's the
no, no,
data
no,
is not.
no. That time you need to understand decision tree is not suitable. Simple.
Okay.
Try with
Yeah.
other algorithm also. See, you will
Uh,
not end up with one algorithm here. Huh?
mhm.
Go to any use case, you try decision tree, logistic regression, random forest, you do multiple algorithms, you try and you compare them. Even for this
Mhm.
use case also, I am directly showing decision tree. It may not happen in real time. You may try other algorithms and you compare their accuracy score, which is having highest, you will select that at the end of day.
Okay.
Get it? Are you getting?
Yeah, yeah.
Yeah.
See, don't
So
stick to only one algorithm. Huh?
correct.
Always try multiple. How you go and when you go to any shop also, you will not buy directly by looking at one shirt, right?
Hmm.
You will try multiple shirts, right? Correct or not?
Finally, we'll select one. Yeah.
See, as a human, we will go and try multiple choices. Similar to that, try with multiple models and finally select the best one which the model is giving us. This is going to happen in every project, huh? Not only while you are learning, even go to real time also, you have to try multiple models. Some people ask you how many models you tried. You have to tell them like at least 3 to 4 models I tried. Out of them, the topmost is this one, so I selected this for the deployment.
Hmm.
Is it
see,
clear,
like
Ranjan?
yeah. So one more question, like
Hmm.
how can, because how can you implement this one in our like in DB activities, something like any we can do that in account usage table, something we have some
You
metadata
have to.
tables,
You
right?
can create a table also, right? Session dot table. Simple.
Okay.
Session
Okay.
dot table will create. Assume I am creating a file here. My predictions I can create a table. Simply add the session is already open right here.
No, no, no. I'm asking that
Uh,
we have that metadata tables, right? Those are
Correct.
some
Uh-huh.
data.
Uh-huh.
How we can implement in Snowflake? I mean, these models and all. What kind of use cases can come so that we can try? Or
Snowflake. See model. See, whatever the ML model, whatever you are using as of now, this is just like a use case level we are discussing. But coming to Snowflake level, see metadata
hmm.
tables and all, you can see the credit, the how credit consumption prediction. Correct, no? With the compute cost, you can
Okay.
predict, right? Yes or no? Environment monitoring, you can go and predict, right? In Snowflake side as a DBA, generally. Are you getting?
Yeah, that's what I just need. I'm just asking what
Correct,
can be the use case.
correct. That's what I'm saying. You have to go and think an application. You need to build and you need to collect what important metrics required for that compute cost or data transfer cost is impacting, right? Similar to this.
Hmm.
See, whatever the metrics that will impact your compute cost, you have to find out that information from metadata, correct or not? And then you have to use
Mm,
them and you need to predict what could be my compute cost next month. Are you getting?
But how do you calculate get those parameters? Like we in the compute cost and all that comes in the
There are
credit table, right?
metadata
It
views
doesn't.
are there. See, you have to go and check it. See, there are so many metadata views. Go to
Yeah,
just
correct. But it will not give you right which one taking what how much of credits.
it's
Doesn't say that
what
one, right? Only the
that is
warehouse cost it
that
will come.
that is what there are so many columns available.
The
Okay.
metadata.
In metadata views. You have to verify. There are some criteria which that is impacting your compute cost. You need to identify because you cannot go and directly get all this information, right, Ranjan? If you are a DBA, for example, you are a
No,
DBA,
I
you
agree
need
your point, but
uh,
in Snowflake we can't identify those things, right? That
you
is the
can
warehouse cost is
see
the
if you see. I'm saying that you cannot 100% go and do that, right? You can
okay.
you can see get the information, existing information, available information. You can go and start it. Correct or not? At
Hmm.
least. See, get the available information, whatever is there, and any additional information does not find, you need to go and create that. Create the column. You can calculate, right? Yes or no? Using a formula? Yes, sir. Are you getting what I'm trying to say? Is it
I mean,
every column what I require will not be available in even Snowflake environment also, right? Sometimes you may need to generate the columns also. That is a part of data science. In some scenarios in data preparation, you go and generate the new columns. If the columns are not sufficient, I did also in many projects. If any new column is really required, I'll generate it with the existing columns.
mhm.
You need to generate that. My data is, for example, storage cost. Snowflake is giving me in KBs, but I need in GBs means I need to convert that, right, using a formula. Yes or no?
Yeah, that is okay.
But that's what I'm saying. You have to do that. You cannot get every solution on fly, Ranjan. You have to do some of the calculations in the background. What is your requirement? First of all, you tell me what you want.
Oh, my, see, we learned this one, right? Logistic regression, decision tree.
Correct,
So I
correct.
just want to I just want to implement in Snowflake how we can do that. That's the my question only,
We are
nothing
doing
else.
these are all Snowflake calls you are using in Snowflake only, but you are telling that environmental specifically how we want to do. Correct?
No,
No.
no, we are taking this dummy data, right? So I'm asking using Snowflake data, right? How we can, what kind of models we
That's
can.
what I'm saying. You can directly connect to a table instead of database, whatever I'm doing here. Say I'm taking a sample data, correct? No? This one you're talking
Yeah.
about. Sample data I'm
Mm.
generating and I'm using it. If it is in a table, if it is in a table, you need to go and connect to the table here, right? Instead of data frame here, I will connect to the table and then I
I
can see the
understood this
data.
one. Yeah, I understood this one.
Uh, no,
I
your question
mean,
your question I understood. You want to directly connect to database table and you have to want to do that.
no, no, no. See, I know how to connect all these things. I know that one. I'm not asking that. I'm asking what kind of model I can predict based on the account users metadata tables, right? Whatever the tables we have, query history, login history, session
Correct.
table,
Uh,
credit, many are there, right? So
correct.
I want to apply this models like logistic regression or the decision tree on those tables by
That
reading.
comes to picture on what use case you want to build, first of all. First, you have to
That
decide.
that is what I wanted actually. I mean, what we
I got it
can.
now. You want some use cases. That's what, right?
Yes, yes. Yeah, yeah. That is
That
what I
now,
want.
now I understood. Understood. I'll give you some examples. Okay, don't worry. Okay.
Yeah.
But first,
So I mean,
I want you to understand what is these algorithms at the base level. Okay.
yeah, that is correct. Yes.
See, if you remember, you only asked, are you going to like cover ML or not? Correct or not?
I mean, I don't know ML, right? That's what I told you.
That's what I'm saying. That's what I'm covering also. You got it?
Correct, correct. Yeah, I'll understand. I mean, I'll practice this one,
You
basics
have to
one.
practice and you practice till random forest I'll cover. And after that, we will try to see some implementation, whatever you mentioned. Okay.
Correct, correct.
The base algorithms, we do not need every algorithm, Ranjan. Okay. At least linear regression,
Mm-hmm.
large regression, decision trees, random forest. These four are okay.
Correct, correct.
Under
Okay.
supervised learning. In unsupervised learning, if you want, let us go with one algorithm with clustering.
Okay.
Once after you've done all this, then we will try to use this particular learning and you will go, as you mentioned, let us try to directly go and use Snowflake environment and try to integrate and do something. Okay.
And in
Oh.
real time, only this 5 or 6 models is enough to learn
See,
this logistic
there
regression.
are hundreds of models, Ranjan. So
We
whatever
can't do that.
you cannot learn.
Yeah.
See,
Mhm.
until unless you go and get a real requirement of that particular algorithm, I say polynomial
Mhm.
regression. Example I'm giving you. A
Mhm.
polynomial regression we use for curvilinear data. See,
Right.
I should get the curvilinear data in my environment, right? Correct or not?
Mhm.
See, I know. So polynomial regression will help me if my data is in a curvilinear form. But at the end of the day, until unless I'll not get curvilinear data, I cannot implement it, right?
Right.
You should know that at least. See, there is a linear regression is there. In the regression itself, we have 21 types. Can I learn all those?
No.
No, I cannot. At least linear regression is okay. In that simple and multilinear is fine. And some people will go with lasso and region elastic net also. But in the Snowflake's perspective, when you are doing for regression, at least try 1, 2, this, 3, 4. Okay. When you come to classification, you have more. like decision tree, random forest, logistic regression, and we also have like support vector machines, KNN. There are so many, naive Bayes. But you need to go with according to the data again. Correct, no? See, more categorical data, if you have, go with decision trees. So there are some challenges with decision trees also sometimes, because most of the ML models will overfit. Overfit means your results will not come up to what you are looking for. Such kind of issues can be resolved by using random forest again. Are you getting? So whatever the challenges in one algorithm can be eliminated in other algorithm by optimizing. Correct, no?
Right.
So that is the reason. That is the reason this one algorithms. Correct. So why we have to learn also, because if one algorithm is not going to help me, how can I go and get an alternative? That is why we are learning this. You got it right?
Yes, yes.
Now this random forest, and which we are going to learn next, will be similar to decision trees, but that is a forest which is a collection of decision trees. Simple.
Okay.
A forest is a group of trees only, right?
Yeah.
So a decision tree is one random decision tree, and random forest is a collection of similar random decision trees. Simple. And my algorithm will try to build I say how many trees I want also I can mention there, 100 trees or 200 trees. Is it clear?
Yes, yes.
So when you are learning, when you are learning, first you understand the what is the importance and when to use that use case. All this whatever I'm showing you, these are all just you to understand what type of data concepts. When the implementation come into picture, then you have to recollect whatever you are learning and integrate. Simple. Then we will directly connect to database table and we will pull the data.
Correct.
Go ahead. Ramesh, are you following?
Yeah.
But only thing important here is you need to understand what is its algorithm and practice.
Yeah.
Because if you practice, you will get more clarity also. Why? Because see, when you are learning this data science or ML and all, you need to do multiple use cases. Then only you will get more clarity. If I gave an example, means you need to go and get some new and some other data, and you also need to do some kind of your side also you have to do some kind of like additional work.
Right.
If you don't do that, you cannot explore the things, right? Correct or not?
Yeah.
So that's what I'm saying. I'll give some assignment. You try that also. Are you getting?
Yes.
Yeah.
So I'll give some other use case with some sample data. You try to implement same thing, maybe same thing, similar one is also fine. Clear?
Yeah, that's sure.
That is how you can
So
learn, especially this ML and data science. Because normal application development is people can learn, anybody can learn, but people who are learning ML, data science, and this particular kind of AI and all, this is the way to learn. Data is important mainly.
Right.
Okay. Any questions?
Yeah, so you're showing these two versions of this scripts, right? Like one Streamlit and this one, the one it's showing in the screen, it without Streamlit, right? So that without Streamlit, if I run, like, because last time we got some errors, right? Logical regression, that is not it.
This script is not getting any errors now. I resolved everything. You can try directly with the Streamlit and you can remove Streamlit also, you can try.
So without one, what are the requirement.txt, like what are the do we have that one also?
Requirement.txt, mainly Snowflake ML is required generally.
Okay.
Extra.
There's no versions,
No
right?
versions is
Updated,
required. No
correct?
versions is required. Everything is fine.
Okay, we'll try that one.
You try that. I'll share anyway. Okay. Okay, then that's all for today. And we'll connect tomorrow same time, and we'll try to discuss about random forest, and we'll try to see if possible. I'll discuss about clustering also. Okay.
Okay.
Okay then. Yeah. Thank you.
Thank you.
Thank you.